A polyhedron is a figure consisting of 4 or more faces that are polygons. They meet along an edge, and when 3 or more edges meet, they create a vertex. Regular polygons all have identical faces that make equal angles. Irregular polygons all have different faces that make the angles at the vertices different. Polyhedron comes from poly meaning many and hedron meaning face. This is the Euler's characteristic. It relates the number of faces, vertices, and edges of a polyhedron. If you are given a polyhedra and only have 2 of the 3 defining characteristics, you can use the Euler characteristic to find the third by using 2 equals v minus e plus f. You can always find the number of edges, vertices, and faces of the polyhedron.
Okay, so when you look at polyhedras, they go by dimensions. So this entire thing is 3 dimensions, which is the volume. And then if you look at it this way, that would represent 2 dimensions, which is a face. And if you look at it this way, that would represent 1 dimension, which is an edge. And then believe it or not, there's a thing called 0 dimensions. That's a vertex.
This is the tetrahedron. It has 4 equilateral triangle bases, 6 edges, and 4 vertices. This is the cube. It has 6 square faces, 12 edges, and 8 vertices. This is the octahedron. It has 8 equilateral triangle faces, 12 edges, and 6 vertices. This is the dodecahedron. It has 12 regular pentagon faces, 30 edges, and 20 vertices. And this is the isosahedron. It has 20 equilateral triangle faces, 30 edges, and 12 vertices.
Okay, now we're gonna get cray with all of our polyhedrons. So these 2 are regular ones, and you can tell because they both have the same, all the same faces. When you put this one together, all of its angles are gonna be the same. This one's called a triachus tetrahedron. I think it's kind of cool because each face is kind of like a pyramid, so it's like 4 different pyramids on each side. But it has 12 faces, 18 edges, and 8 vertices, so that's fun. And then you have this one, and it's a rhombic dodecahedron, and it has 12 faces, 24 edges, and 14 vertices. And I'm sure people can make it look a lot prettier than that. And then you have these, and these are cool. And these are all irregular. This is a pentagonal cupola. This one gave me a paper cut, that's why it looks like that. But it has 1 pentagon face, one decagon face, 5 square faces, and 5 triangular faces. And so 12 faces altogether. And then it has 25 edges and 15 vertices. And then you have this one, and it's an elongated square dipyramid. And it has 12 faces and 20 edges and then 10 vertices. And it's pretty much like comprised of triangles and squares, rectangles, however long they make it. So that's cool. And then you have a decagonal prism, and that's comprised of rectangular faces and 2 decagonal faces, so 12 rectangular faces, 14 faces altogether, and it has 36 edges and 24 vertices. And then our last one that we have is a pentagonal antiprism, and it looks like it's going to be super cool in this one, but it actually kind of just looks like the decagonal prism. But it has 2 pentagonal faces and then 10 triangular faces. And so 12 faces all together, and then 20 edges and 10 vertices. And those are regular. So yeah.